if you graph this one correctly, it should look like this. When I see it says absolute value of x minus 2 is greater than 4, you're going to have open circles, correct, on the graph? And I think one of the open circles is going to be at 6. And you want to be greater than 6, correct? And the other open circle, I believe, is at negative 2. Yes? And it goes this way. And, you know, that was not helpful for many of you. All I did was put down an answer. I did not show how to get it. I did mention that these things are like barbells. And I mentioned that it is very helpful when you graph to put the little balance point. Remember we did this last time? We had a balance point of negative 3. What would be the balance point for this little barbell? Positive 2. Okay? And I claim that's very significant. All right, and I'm going to talk about it shortly. But first of all, let me work out the work that you should have done. And so here's what I'm picturing you guys did. You wrote down something like x minus 2 is greater than 4, or, well, negative x minus 2 is greater than 4. Sometimes I have students skip this step. They'll just write x minus 2 is greater than 4, or x minus 2 is what? Why less than negative 4? Why is it less than? Now you see it, right? Because I really multiplied by that negative on both sides. Who's with me so far? Okay. So I really do get x is greater than 6, or x is less than negative 2. And so you really do get the picture I'm talking about. Go ahead, Jenna. One of the keys to understanding this section is to understand the idea of domain. Domain is the set of all possible, what is it? Inputs, right? Now the domain is all real numbers. You can put in any x you want for these functions. So I guess what I'm saying is that you see how I've been drawing these arrows? I've been drawing these arrows to represent the different cases of absolute value, right? Remember, you can't see the arrows. These arrows. And those arrows, right here and here. Well, I didn't draw the arrows on that one. I drew them on this one. But here's the thing, guys. When I write down f of x is the absolute value of x, you might remember we also defined that as a piecewise function. Sometimes f of x equals x, and sometimes f of x equals what? And when is that? Well, it equals x when, sure, on the interval, if you want, 0, infinity. And it's negative x if we are, sure, so from negative infinity to 0. Does that make sense? Okay. I could even write x is an element of these sets if I want to be really fancy. I'm not a big fancy person, but... Okay. Back to here. There were two cases. Now how do you know which case you're in? Well, we're in this case, right over here, anytime that x plus 3 is greater than 0, greater than or equal to 0. In other words, if x is bigger than or equal to what? Negative 3. And over here, we do this if x is less than negative 3. There's always cases when you take away absolute value bars, if you want to do it piecewise. Okay? And that idea, I think, is important. Oh, But there's a totally other understanding of absolute value that I want to remind you of, and it's geometric. Here, back to this. When I write down absolute value of x, what did I tell you guys that means? Distance from 0. So if I say absolute value of x is greater than 2, what does that graph look like? Well, here's 0. What does it look like? X is greater than 2, or x is what? Less than negative 2. Because these points I'm coloring in are the ones whose distance is greater than 2. Distance from what? 0. Now here's the thing, guys. You guys have studied transformations. I told you that's the key to this course. In this problem we just did today, you didn't have x in the absolute value. What did you have? X minus 2. That's like what kind of transformation? It's a horizontal what? Shift. Now look. This one down here, the center was 0, and the distance to either side was 2. Well, greater than 2. Look at this one. If you remember, I looked at this thing and I graphed it. I didn't have any equations written out. Because when I read this, what's the center of that graph? It's not 0. What is it? Remember x minus h? Same idea. I knew it was going to be centered at 2. And now I want the distance away from 2 to be greater than what? Greater than 4. So I go 4 away on this side or 4 away on that side. You could skip everything in green if you do that. Kind of nice. Here, let's see if it works with the other one. What would be the center of this graph? Negative 3. Remember that? And then what's the distance? The distance away from negative 3 is less than or equal to what? 5. Go 5 away. That's where we are. Why is it negative 3? That's a good question. Because remember our formula was always like x minus h? Okay? But if it says plus, that's like minus what? Negative 3. That's why I did negative 3. But we're kind of used to that with other things. So I want to make sure I shared that with you guys. That could be quite helpful when you take, well, if you take today's section, 2.2 is actually absolute value functions. But the homework tonight is going to start with just solving absolute value equations. So I want to start with number 4. And then I'll jump to one that we just worked on. So it says 4 minus the absolute value of x equals 3. Okay? And so if I'm trying to solve a problem like this, hopefully this is somewhat review for you, but I want to give you some steps just so that we're very clear about what you want to do. You want to first isolate the absolute value. And then in step 2, remove the bars, and what happens is we get 2 cases. And we'll see if this makes sense to you guys. All right? So I feel like I'm back in beginning algebra class, and I'm trying to isolate something, and so what do I do to both sides of this equation? Subtract 4, right? And so I get negative absolute value of x equals negative 1. And so the absolute value is not isolated yet. So when what do I do next, by the way? Divide by -1 or multiply by -1, either way. And so I get absolute value of x equals -1. That's a dumb problem. What happened? Oh, +1. Whew. By the way, what would happen if you had absolute value of x is -1? You'd have no solution, right? So I could very easily make an equation that would have no solution. And why would you get no solution? Because absolute values, they're always positive or 0 because they represent distance away from 0. Okay, so that's good. At least we can still do this one. And so now I'm on step 2. I'm going to remove the bars, and we get 2 cases. Well, what are the 2 cases? Either x must be +1, and you get that just by removing the bars, or what's the other possible case? X equals, what is it? -1. And when I talked about graphing the solution, I really like to do that with absolute value problems because I think you learn a lot. So I like to graph 1, and I like to graph -1. And I like to put those there. And the other thing I like to do is I like to talk about the point that's directly between the 2 solutions, which in this case is what? 0, right? I like to just represent 0 happens to be right there. Okay. Now moving on to the problem I put on the board. Oh, the problem I put on the board is an inequality. Is less than or equal to 5. Now, I could have made it just like this one where you have to isolate the absolute value bars to start. But I didn't. But what I'm going to say is, suppose you had a negative sign in front and you multiplied by a negative. Just a reminder, what would that do to this problem? You have to switch that inequality. You guys remember that rule? Just look for that tonight, okay? Because it's going to happen at some point. All right, so let's see. Well, if I have, let's see, x plus 3, I get 2 cases, right? What are the 2 cases that I get? X plus 3 is less than or equal to 5. Okay. The other case I get, well, I guess the way to say it would be that negative x plus 3 is less than or equal to 5. See, there's a step in the problem above that I kind of omitted. And I'm going to put it in blue here. In the problem above, I had either x equals 1 or the opposite of x might be +1. When you take away the bars, what we understand is that the stuff inside the absolute value bars, whether it's positive or negative, the absolute value bars make it positive. And so that's why I get 2 cases. Now, of course, how did I get from this blue to this purple? Well, I multiply both sides by what? -1. And so what I write down here now, x plus 3 is less than or equal to 5. What am I going to write here? X plus 3 is what? Greater than or equal to -5. Okay? So that's what I wanted to remind you about, is that rule about negatives. And by the way, I see the word or here. Do you guys know what word goes here? How do you know? Less than and. Understand? That's kind of a weak understanding of why. I didn't explain why. That's one of the reasons I don't like that. So I'll try to explain why today too. And the way I can explain why is to look at the picture. Well, let's finish the problem and then we'll graph the solution set. So when we finish the problem, we get x is less than or equal to 2 and what's the other one? greater than or equal to negative 8. Very good. Okay? And by the way, do remember that we do have interval notation. You can guarantee that's going to be on your exam. And I'm putting brackets because, well, we're allowed to be equal to it. And in the interval notation is the intersection sign. And so over here, I guess I could write negative 8, comma, positive infinity. Oh, wait. My 8 flipped over. Negative 8, positive infinity. Oh, wait. I need what? Bracket. Okay, we're trying to clean that up. I need a bracket because we're allowed to equal negative 8. Anyways, that's the interval notation. That's just a quick review. Let's do our graph. So what points do I want to graph? Well, we better graph 2. And we're moving which direction from 2? Which way do I want to go? This way, right? To the left, towards negative infinity. I also want to be greater than or equal to negative 8. Okay? Now, almost done. One more step. I want you to graph. See, to me that looks like something from the weight room. Right? A big barbell. Okay? I want you to graph where you should put your finger if you're going to pick it up with one finger. You want it to balance. Where would the balancing point be for that barbell? Let's see. Right in the middle. You know what I could use is I could use the midpoint formula, right? I could go, well, it's negative 8 plus 2. I'll only need just an x-coordinate because it's only one axis. Over 2. So what do you get? What is it? What's the point right in the middle? Negative 3. I like putting negative 3 on my picture. Why? Because you can learn a lot about absolute value if you put negative 3 on the picture. Okay, I'm going to work out number 10 on the screen now. One of the cases is simple. You just take away the bars. 2x minus 1 is x plus 1. The other case, let's see if you guys got it right, should look like this. Negative 2x minus 1. Notice I have parentheses. Equals x plus 1. Now there might have been some of you that put the negative sign on the other side with parentheses. And for equations, you're correct. But notice I showed you an inequality today, even though we're not doing those yet, because I want you to get in the habit of putting the negative where the absolute value bars were. It's going to save us later. Okay? So let's see. What happens now? I guess if you solve for this one, you guys get what? X equals 2, right? Subtract x, add 1. Am I right? Let's see. I'll go slower. X minus 1 equals 1. So if I add 1 to both sides, yeah, I'm getting x equals 2. Okay? Or, this is an OR problem. Equations are going to be OR problems. Over here, let's see what happens. I'd probably distribute the negative. So I'd write negative 2x plus 1 equals x plus 1. Now if you subtract 1 from both sides, you get negative 2x equals x. Now what do I do to both sides? Let me, okay, I can subtract x. That works. So negative 3x now equals what? 0. And I could divide both sides by negative 3. and I get x equals 0. So supposedly, those two solutions are what I need for this graph. For this equation. Can I see if they work? Let's see. If I put in a 0, that should be easy to check. What does the left-hand side equal if I put in a 0? Well, it'll say absolute value of -1, which is 1. And you can see you'll get that on the right. And similarly, if you put in a 2, you're going to get 3 on each side. So they really are two solutions to these equations quite often. Okay? All right. We've also seen you can have no solution to an absolute value equation. I want to talk about something like number 17. Number 17 says absolute value of 3x plus 1 equals absolute value of 4x. Now, we have to take away the absolute value bars and split it into cases. And then we have to take away the absolute value bars and split it into cases. We're going to have to, right? Do you guys see what I'm talking about? We're going to have like 4 different situations. But it turns out that, cha-ching, part of the exercise is prove that if these bars are equal to each other, absolute value of f is equal to the absolute value of g, you really only need to worry about 2 cases. Now, how do you prove that? You know how you prove it? You try and do all 4 cases. Once. You do it once, and then you realize, oh, I didn't need to do that. Okay? So, for example, the shortcut is, if you have the absolute value bars like this, all you need is 3x plus 1 equals 4x, or 3x plus 1 equals negative 4x. Okay? That's all you need. But maybe one thing to say, warning, inequalities could be more complicated. Well, I guess you're right. If I were doing it tonight, that's what I would do. I would also take care of these cases. Like, it looks like what I did so far is this. 3x plus 1 equals 4x, or 3x plus 1 equals minus 4x. That's what I did so far, is I only took away one absolute value bar. But what I'm telling you is you could take away the other one and it will work. And if you try it tonight with taking them both away, you'll see why. That's kind of the point. Okay. From there, I think you guys are fine, so I'm going to move on. We have a lot to do. Okay. The next problems are graphing problems. And rather than go crazy here, I want to look at, say, 22 to 27. Here's a whole bunch of functions. Hey, take a look at 23 as our first example. I'm saying you guys know how to graph y equals the absolute value of x. And I know from your homework you guys learned a lot about transformations. So tell me how you're going to graph 23. Take your v and then do what to it? Shift it up 4. You guys with me? That's all you're going to do. When it comes to something like 26, first I work on this guy. The input. What's that do? That's what kind of shift? Horizontal shift. Which way? To the left, 4. And then this guy and this guy work on the output. I'll do the 3 next. The 3 is a vertical stretch. Yes, question? Yes, that's why I'm doing the multiplication 3 before I do the multiplication, before I do the addition -4. But you want to do, well, that's because I'm working on input before output, okay? Separately, right. No, yeah, you'll be okay. You have to do the inputs, you have to do the outputs, okay? But for the input, we want to do that +4 before we do the vertical stretch, or horizontal stretch. And that's what, remember I ran into problems last week on one of these? I did the multiplication first. I'll do an example like this, because we're going to go over homework here in a second. I think with those you'll be fine. I think that maybe the place to worry about is when we get down to some of these other ones. So you tell me what you want to see, 28, 29, 31, or 32. Number 2 from multiple 4, and that'll be it. So number 32, we're going to try and graph this function. F of x equals absolute value of x plus 2 minus absolute value of x. And that's really, really challenging. Because there's all kinds of absolute values, and there's all kinds of cases to take into account, right? Here, let's do some practice inputs and outputs. What's f of 3? That's the easiest one I could have given you. That's because then this is positive, so I get 5 minus 3, I get 2. All right? So over here on the side, I already know, oh, that's a horrible graph. Try that again. That if I go to 3 for my input, 1, 2, 3, my output is 2. All right, let's compute something else. Let's compute something like f of 0. Well, then I get 2 minus 0, and that's 2. Okay. So f of 0 is also 2. I could do this all day. We want a better method. Notice when I put in something like f of -1, well, I get, let me work this out more slowly. I get 1 here minus, but this becomes a positive 1. So this is the first time I didn't get an output of 2. I got an output of 0 this time. Do you guys see that? So that says that one of the points on the graph is -1, 0. You guys with me? And I claim there's one more thing that could happen. If you put in something like f of -4, well, now you'll be taking the absolute value of a couple of negative numbers. And so what you're going to get is you're going to get, let's see, the absolute value of -2 minus the absolute value of -4. That's 2 minus 4, which is what? -2. And so it looks to me like, let's see, the absolute value of, let's see, f of -4, so 1, 2, 3, 4, has an output of -2. And so far, I don't see very clearly what the shape looks like. It doesn't look like a V like I'm used to. Okay. And that's because this is hard, because I need to learn a trick. And so here's the trick. Over in purple, I want to graph y equals absolute value of x. What's that look like, guys? A V, right? I want to point out that it's really two pieces. You have this green piece, which is on part of the line y equals x. And you also have this black piece. And what line is that a piece of? Y equals -x. Remember how taking away the bars You have two cases, x or negative x. It depends where you are. And so what you should know is that there's another way to write y equals absolute value of x, and that is to define it piecewise. Now, we've done this before in the course. Y equals x if x is positive or equal to 0. Y equals negative x if x is less than 0. Does that make sense? In other words, I'm on this line. That's how I graphed the black. And I'm on this line. And that's how I graphed the green. Now, once I understand that, I have a chance at problem 32. And that is, I need to rewrite f, and I need to split it into cases. I tried to demonstrate those cases with these inputs and outputs. So let's see if you follow. F of x equals. Well, what are the important values? And what I mean by that is, notice that 0 was an important value here because it's where we changed from going from x to negative x. Well, I claim 0 is an important point here too. So 0 is going to be an important point. What else is going to be an important point? There's one more. Yeah, almost. It has to do with this part here. Oh, we lost it. X plus 2. When will that change from x plus 2 to negative x plus 2? Okay. Yeah. What number did I put in for x that made this happen? Right here, right? Do you guys see when I put in negative 4, that was the first time that this guy became a negative inside the absolute values? Actually, it's going to happen as soon as I get past negative 2. All right? So there are 3 cases to worry about. I need to worry about this interval from negative infinity to negative 2. I need to worry about this interval from negative 2 to 0. And then I need to worry about this interval from 0 to infinity. We better put a bracket somewhere. Let's put a bracket here and a bracket here so that we include 0 and negative 2. Okay. And now I'll show you how this works. Hey guys, if we put in a positive number, that's just like we did at the beginning. That was very simple. By the way, what do we get as our answer every time? And that's because when you go from 0 to infinity, when you take away the bars, everything stays positive. So it's x plus 2 minus x. By the way, what is x plus 2 minus x? 2. That's why we got 2 every time. When I'm between negative and 2 and 0, I'm still going to get x plus 2. But what I'm going to subtract is not x anymore. Now I put in negative x. And I'll simplify what that is in a moment. And then the last piece is even weirder. When I do put in a negative number, I get negative x plus 2 minus negative x. This is tough. Well, let's simplify it and see what happens now. So I'm going to write the final answer, if you want, right over here. F of x equals, and we want to do it piecewise. So let's see. Between 0 and infinity, What happens when I simplify x plus 2 minus x? What do I get? 2. The output is 2. Well, that tells me something about the graph. That tells me on the graph, from 0 to infinity, the output's always 2. No wonder it hit those points. Coming back down here, let's do the bottom one next. We're going from negative infinity to negative 2. And I want to simplify this ugly expression here. That's a lot of algebra to do. So what does that equal? When I distribute all those negatives, I get negative x minus 2. And then I have minus negative x. What does that become? And so what's it equal? Negative 2. And so this function has a value of negative 2 when I'm on that interval. So going back up to the picture, where do I go? Well, anytime I'm less than negative 2, here's negative 2, negative 2, the output is going to be along negative 2. Hey, you know what? We saw a graph like this once, piecewise. I'm sure of it. Well, almost. We'll see what happens in the middle now. This is maybe the trickiest part. And I'm almost out of room. I've got so messy. But let's finish up. This step right here is what I'm trying to do, right? What happens between negative 2 and 0? And where the heck am I going to do that? How about I do it up here in black? So what is the value of the function when we're between negative 2 and 0? It's x plus 2 minus negative x. But what does that equal? 2x plus 2. Do you guys know what the graph of 2x plus 2 is? It's a line. Slope is 2. What's the y-intercept? That's why the graph goes right through 0, 2. See, it's on the line that you guys studied last night when we studied linear functions. And that is the hardest kind of problem you'll be assigned tonight, I would say.